Okay, good day, students. No, so we are now going to discuss the third part of our lesson, which is calorimetry. No, so ito na yung last part natin, which is we're going to discuss calorimetry. Okay, so one moment, punta natin ngayon sa lecture natin for today. Okay. Okay, so let's start with calorimetry. So, from our previous lesson, ang alam pa lang natin na way to calculate Q ay si heat at constant pressure. So, sabi natin from our last lesson is si QP or heat at constant pressure is simply your enthalpy. But actually, there are other ways, no, to calculate heat, and it can be done experimentally. So, from our previous session, mapapansin nyo kasi na yung mga binibigay sa ating value as is na yon. So, binigay na siya sa atin na ganun na lang. So, you might be wondering, saan nanggaling yon? So, lahat ng values natin na nasa thermodynamic data ay nanggaling sa calorimetry. So, ginagawa yung calorimetry sa laboratory or ginagawa siya as way to experiment yung mga substances natin, and then malalaman natin yung energy. So, yung mga values na nandito is nanggaling sa calorimetry. So, now, let us define what calorimetry is all about, no? So, heat changes involved in physical or chemical processes are measured with a calorimeter. So, calorimetry is the measurement of heat changes involved in any processes. So, calorimetry, no? So, in calorimetry, we can actually calculate heat, no? And then, at the same time, yung heat na nakukuha natin sa calorimetry, it is dependent on two variables. So, kung titignan natin yung formula natin dito, meron tayong temperature and meron tayong mass. So, yung heat na nakakalculate natin for calorimetry is dependent sa dalawang factor na to. So, for temperature kasi, sinasabi lang dito na pag mataas yung temperature natin, mataas din yung heat na matatransfer. So, directly proportional yun, no? So, pag mataas yung temperature natin, of course, ibig sabihin nun, mas marami siyang heat na kayang i-release, no? Or ibigay. And then, for mass naman, if we're talking about mass, nakadepende naman yung mass natin doon sa heat. Kasi pag kunwari, mas mataas yung mass natin, higher yung mass ng matter natin, hindi atom, matter natin, mas marami yung energy na kailangan para initin yung mass na yon or yung matter na yon. So, bigay tayo ng example, no? So, one example na naisip ko is, for example, meron kang 5 ml na tubig versus 1 ml na tubig. So, between the 5 ml water and the 1 liter water, sinong mas mabilis pakuluan, no? So, sige nga, sino mas mabilis pakuluan? Yung 5 ml na water or yung 1 liter? Siguro, kung naririnig ko ngayon, you might be answering yung 5 ml of water, no? Si 5 ml water yung mas mabilis pakuluan in terms of mass kasi mas konti lang yon. So, yung energy na kailangan para pakuluan yung 5 ml na tubig is mas konti compared sa 1 liter na water. Okay? But at the same time, same lang silang kukulo at 100 degrees Celsius, no? So, again, pag mas mataas yung yung mass ng matter natin, mas mataas din yung energy na kailangan niya. Okay, pag mas mataas naman yung temperature, meaning nun, mas mataas yung heat na kaya niyang i-produce. Ngayon, you might be wondering, no, meron tayo ditong C. Sino kaya tong si small letter C? Si small letter C, yung tinatawag nating specific heat. Okay? So, si specific heat naman is constant yan, no? And each material has their own specific heats. That's the reason why some materials dissipate heat quickly rather, and some do not. So, anong ibig sabihin nito? So, as you can see to our left, meron tayo ditong table kung saan nakalist dito yung mga specific heat ng mga materials natin. So, sabi natin kanina na meron tayong mga materials na mas mabilis mag-release ng heat or mag-dissipate ng heat kumpara sa ibang materials. So, let's take for example si aluminum and gold. So, zoom in natin ng konti, no? So, as you can see, ito si aluminum and this one is your gold. So, between aluminum and gold, mas mataas yung specific heat ni aluminum. So, dahil mas mataas yung specific heat ni aluminum, anong ibig sabihin nito? Ang ibig sabihin nito is that pag mas mataas yung specific heat ng isang material, mas marami siyang energy na kayang i-take. And because mas marami siyang energy na kayang i-take, mas matagal siyang lumamig. So, between aluminum and gold, mas mabilis mag-release ng heat si gold dahil mas mababa yung specific heat niya compared kay aluminum. And that's the reason why students, no, yung aluminum and then ano pa ba? Si iron, no? Ito si iron tsaka si copper ay madalas ginagamit sa mga cookware or mga what do you call this? Cooking materials natin, no? Kasi mas kaya nilang i-maintain yung heat pag nasa heat source sila. Okay? So yun yung definition natin ng specific heat. Pag mas mataas yung specific heat ng isang materials, mas matagal siyang lumamig. Yun lang yung ibig sabihin nun, no? So, that is your letter C there. That is specific heat. Okay? Now, let's move on to this second formula. So, this is your first formula, no? For calorimetry, and this is the second one. As you can see, for the second one, meron tayong capital letter C. So, sino naman tong C? Capital letter C. So, si capital letter C yung tinatawag nating heat capacity. Okay. So, for heat capacity, ang difference lang niya sa specific heat is si heat capacity is minultiply mo na yung mass times your specific heat. Okay. So, yan yung heat capacity natin. Mass times specific heat. So, bakit kaya, no? Kailan ginagamit tong equation number 2 natin, which is heat capacity multiplied by the change in temperature. So, ginagamit natin to, itong second equation natin na to, pag meron tayong tinatawag na bomb calorimeter. Okay? So, yung bomb calorimeter, i-discuss natin yan later on our lesson for today. But, explain natin bakit ginagamit to sa bomb calorimeter, no? So, ginagamit siya sa bomb calorimeter kasi merong special device na ginagamit or special instrument na ginagamit sa bomb calorimetry kung saan sobrang bigat nung instrument na yon. So, dahil sobrang bigat ng instrument na yon, parang no need na nating timbangin. Kaya instead of using mass, okay, or instead of using the first equation kung saan meron yung mass, for equation number 2, we don't use, hindi na natin ginagamit yung mass ng object. We just simply use heat capacity kasi nga, sobrang bigat nung instrument na ginagamit for bomb calorimeter. Okay? So, pakita na nga natin kung anong itsura ng isang bomb calorimeter. So, here, as you can see dito, yan yung itsura ng ating bomb calorimeter, no? Imagine, titimbangin mo yan, tignan natin kung hindi ka mapagod or tignan natin kung hindi ka tingnan natin kung makuha mo yung specific or yung accurate na timbang nitong material na to, 'di ba? Imagine every time na mag-experiment ka, kailangan mong timbangin 'yan, 'di ba? Sobrang nakakapagod. Okay, so yan lang naman yung something na kailangan yung tandaan dito, no? So, ginagamit si equation 1 for smaller object, no? So, you might be wondering kasi ano yung difference ng 2. So again, si equation number 1, ginagamit natin siya for smaller objects. Kaya kino-consider natin yung mass for this equation number 1. For equation number 2 naman, ginagamit natin to for bigger objects or yung malalaki yung timbang. Okay? And that's the reason why here we just simply use heat capacity, which is your mass multiplied by your specific heat. Okay? Again, itong change in temperature, itong delta T, ano yung itsura niyan? Or paano yung equation na yan? Again, sabi natin pag meron tayong delta T, paano gagawin dito? Lagi siyang final minus initial. So, yung final temperature natin subtracted with your initial temperature. So, yan yung ginagamit, ito yung ginagamit nating formula for the change in temperature. Okay? Moving forward, let's try to apply this two equation that we have learned to the following example down below. Okay, zoom out lang natin sandali para mabasa natin yung question. Okay. So, ito yung question, ito yung problem number 1 natin for calorimetry. Sabi dito, A 466 gram sample of water is heated from 8.50 degrees Celsius to 74.60 degrees Celsius. So, calculate the amount of heat absorbed in kilojoules by the water. So, tinatanong tayo yung heat, no, na na-absorb ng water. Okay? So, as you can see, in this problem, no, okay, bago natin sagutan, let me ask you a question, no. Anong equation yung gagamitin natin? Yung equation 1 or yung equation 2? Okay? So, kung yung sagot nyo is yung equation 1, then you're right, no? Bakit equation 1 yung gagamitin natin? Kasi if you're going to look at the problem, binigay sa atin yung mass. Okay? So, because meron tayong given na mass, then we need to consider that mass in our calculation. So, ang formula lang natin na gagamitin is yung equation 1, which is heat is equal to mass times specific heat change in temperature. Okay? Very straightforward lang yung formula natin, no? Now, we input all the values. So, that is 466 grams multiplied by specific heat of water, which is 4.184 joule gram degree Celsius. Okay, students, no, pakitandaan tong value na to, katulad nung pagtandaan nyo sa mga gas constant natin, no. So, please remember the value of 4.184 kasi sometimes sa mga problem natin, hindi na binibigay yung specific heat ng water kasi ina-assume na nung mga gumagawa ng question is alam nyo na or memorize nyo na yung value for the specific heat of water. So again, the specific heat of water is 4.184. So pakitandaan yan, okay? Tapos yung change in temperature is final minus initial, so that would be 74.60 minus 8.50. Okay? So you might be wondering, no, sir, bakit hindi nyo po kinonvert into Kelvin? So again, you have to look at the units within our problem. So, yung binigay na unit dito for the specific heat is degrees Celsius. So, because naka-degree Celsius siya, no need to convert it to Kelvin anymore. Kasi naka-degree Celsius naman yung mga temperature na binigay sa atin. Okay? So, cancel yung grams. Degree Celsius. So, with that said, ang sagot natin dito, again, sabi niya in kilojoules, so automatically divide pa natin to in ng 1,000 pa para ma-convert natin siya into kilojoules. So, cancel yung joules. Ang final answer natin for heat is positive 128.88 kilojoules. Okay? So, paano natin i-interpret yung sagot natin dito, no? Again, feel free to post the video para makalculate nyo by your own, no? So, ngayon, paano natin i-interpret tong nakuha nating sagot? As you can see kasi, positive yung sagot natin. So, very true lang siya doon sa na-discuss natin about heat nung nagdi-discuss tayo about system and surrounding relationship. Kasi as you can see dito, no, yung starting temperature natin or yung initial temperature natin is tumaas. No? Tumaas siya. From initial to final, tumaas yung temperature natin. So, meaning, nagkaroon ng absorption of heat. So, dahil nag-absorb ng heat yung system natin, automatically, dapat positive yung value natin for heat, no? So, very true yan sa na-discuss natin last time. So, dahil tumaas yung temperature, automatically, endothermic yung process, so positive dapat yung sagot nyo. Tapos, pag bumaba naman yung temperature, let's say 8.50, tas naging 5 degrees Celsius, then you would assume that your answer will be negative, no? Bakit negative? Kasi exothermic yung process natin. Okay? So, again, everything na inaral natin dito from the very start is na-apply natin yung concept up until to this particular lesson or topic in chapter 2. So again, pag tumaas yung temperature, positive. Pag bumaba yung temperature, that would be a negative value. Okay? Moving forward, sagutin natin yung next question natin. Okay? So ito yung next question natin. An iron bar of mass, 869 grams, cools from 94 degrees Celsius to 5 degrees Celsius. Calculate the heat release in kilojoules by the metal. As you can interpret from our question, something na pwede nyong inote agad is that the process is exothermic. So, bakit exothermic? Kasi yung term na ginamit dito is heat release. And sinusuportahan naman siya ng mga given dito. Kasi as you can see, yung 94 degrees Celsius bumaba into 5 degrees Celsius. So, because of that, we expect a negative answer for this particular problem. So, yung heat dapat natin sa problem na to ay negative. Okay? Again, ang gagamitin natin is yung equation number 1 because may binigay sa atin na mass. Okay? And at the same time, yung binigay sa atin is specific heat, not heat capacity. Okay? So, heat is equal to mass times your specific heat multiplied by the change in temperature. So, very straightforward ulit. Ilagay mo yung mass times yung specific heat, which is 0.444, no? 0.444 joule gram degree Celsius, no? So, from here, i-multiply mo pa siya dun sa difference, no, between the final temperature and the initial temperature. So, that is 5 minus 95 degrees Celsius. Again, hahanapin daw natin siya in kilojoules. So, because of that, divided by the whole equation by 1,000 pa, para ma-convert natin yung joules to kilojoules. Okay, so joules, grams cancel, degrees Celsius. So, our heat is negative 34.34. Okay, so yan yung final answer natin. So, anong implication ng negative sign dito? Ang implication ng negative sign na heat na nakalculate natin dito is that the system actually undergo a exothermic process. So, dahil nagkaroon tayo ng exothermic process dito, which is sabi nga dito, nagkaroon ng heat release yung system natin, we expect that the answer should be negative. Okay? So, again, pag tumaas yung temperature natin, endothermic yung process, positive yung heat. While pag sinabi yung process natin is heat release or an exothermic process kung saan yung temperature natin or yung initial temperature natin, bumaba siya from final temperature. Katulad ng example natin dito, expect natin yung sagot natin ay negative. Kung hindi tumutugma yung sign natin based dun sa question, then maybe we've done something wrong. So, always natin, di ba? I reminded everyone na unahin muna natin yung pag-interpret nung question bago tayo mag-solve. Kasi mas maganda yung alam mo muna yung gagawin mo or alam mo muna yung or rather, alam mo yung ina-expect mo bago ka mag-solve. Okay? So, that is your calorimetry, no? At the same time na students, meron tayong types of calorimetry. Okay? So, meron tayong dalawang klase ng calorimetry dito. So, the first calorimetry is yung tinatawag natin na constant volume calorimetry, which is known to be your bomb calorimeter, while the second one is your constant pressure calorimetry, also known as your coffee cup calorimeter. Okay. So, sa bomb calorimeter, sabi natin, this is a constant volume calorimetry. Zoom in natin sandali . So, sabi natin, for bomb calorimeter, this is an example of a constant volume calorimetry. So, dahil yung nakakalculate natin dito is heat at constant volume, ina-expect natin na yung heat at constant volume will be also our internal energy. So, yan yung relationship natin na na-derive from our previous lesson. And yung coffee cup calorimeter, sabi dito, this is your constant pressure calorimeter. So, dahil ito yung constant pressure calorimeter, yung heat na makakalculate for a coffee pangitong cue natin. Yung heat na makakalculate natin for a coffee cup calorimeter is actually our enthalpy. O, diba? So, at the same time, kunwari, may problem tayo, no? Yung problem natin, of course, bomb calorimeter yung example, pero instead of the delta U yung pinapahanap sa atin, yung delta H yung pinapahanap sa atin or yung enthalpy. So, pag kunwari, bomb calorimeter yung problem, tapos pinapahanap yung delta H, then we have to use the equation na na-derive din natin from our previous lesson, yung relationship or yung comparison between the delta U and delta H. So, ano yung formula natin from our previous discussion? So, ano yun? Yung formula natin na na-derive ay yung delta U is equal to delta H minus delta N of gas, RT, no? Times RT. Okay. So, for example, bomb calorimeter yung problem, pero instead of the delta U yung pinapahanap, yung delta H yung pinapahanap, we have to use this formula. No? So, ganun lang din dito. Vice versa. Paano pag coffee cup calorimeter naman yung problem, pero pinapahanap sa atin yung delta U, then we have to use this relationship between the delta U and delta H to calculate the missing energy. No? So, pwede nating i-apply ito. Okay? So, let's have an in-depth discussion, no, for each of these two types of calorimetry. So, let's start with the bomb calorimeter. Okay, so zoom in natin yung bomb calorimeter para you can actually look at the labels here. So, again, itong bomb calorimeter, this is your constant pressure, constant volume calorimetry. Okay? So, discuss natin kung ano yung nangyayari dito sa bomb calorimeter, no? So, as you can see, meron tayo nung calorimeter mismo natin dito. Yung walls ng calorimeter natin dito is adiabatic, o yung container natin dito is adiabatic. From our previous lesson, no, sabi natin yung adiabatic is a type of wall kung saan walang energy na kayang pumasok or lumabas. So, for example, experiment tayo using a bomb calorimeter, yung temperature sa labas ng bomb calorimeter ay hindi makakapag-interfere dito sa loob or dito sa reaction na nangyayari sa loob ng calorimeter natin. So, bakit hindi siya makakapag-interfere? It's because adiabatic yung wall natin. And yung pag sinabi nating adiabatic yung wall natin, kino-consider natin yung system natin as an isolated system. Okay, ngayon, let's discuss kung ano yung other parts ng calorimeter natin. So, as you can see, meron tayong container dito or the bomb cell, no? So, dito sa bomb cell na to, dito natin nilalagay yung sample. Andyan yung sample. And at the same time, dito nangyayari yung reaction. Okay? Or dito tayo nagkakaroon ng chemical reaction. So, idilalagay natin yung sample natin dito. Tapos, of course, yung bomb cell, siya yung kumbaga nagse-separate between the sample from the water. So, meron din tayong water dito. So, ano yung silbi ng water sa loob ng calorimeter? Yung silbi ng water sa loob ng calorimeter ay siya yung mag-work as a way para ma-absorb yung energy. So, for example, di ba, magkakaroon ka ng reaction dito sa loob ng bomb cell. So, of course, pag nagkaroon ka ng chemical reaction, meron siyang energy. So, yung energy na manggagaling dito sa sample natin is i-release lang doon sa water. So, yung water, of course, i-absorb niya yung energy na nangyari sa chemical reaction. And from there, pwede siyang ma-read nung thermometer natin, no? So, yung thermometer, siya yung of course, yung reading ng thermometer, siya yung magdedetermine kung gaano kataas or gaano kadami yung energy na nangyari or na-facilitate dun sa chemical reaction. So, ganun lang nangyari dito. May reaction sa loob na tong bomb cell, tapos of course, dahil may reaction doon, yung energy matatransfer sa water. So, yung water i-absorb yung energy, and from there, pwede nating ma-read yung changes in temperature ng water. So, paano natin mariread yun? Meron tayong gagamiting thermometer. So, kung ano yung na-read ng thermometer, yun yung energy na rinelease nung sample natin sa loob nung bomb cell. Okay? So, actually, ito yung ginagamit namin as chemists sa mga products natin or yung mga food products, or ito yung ginagawa ng mga chemists natin sa mga pagkain na nabibili natin. Kasi again, sabi ko nga sa inyo, hindi lang chamba-chamba or hula-hula yung mga energy na makukuha mo sa mga pagkain. Kasi 'di ba, if you look at the food that we consume, no, especially yung mga commercial foods natin, like for example, yung mga biscuits, yung mga fudgy bar natin, makikita natin may mga energy yon. So, dito nila mini-measure yung energy na makukuha sa pagkain. So, susunugin yun, tapos i-measure dito using the thermometer. And then, yung nakuha nilang reading, of course, yun yung ilalagay nila dun sa likod ng label ng pagkain natin. Okay? So, yan lang naman yung concept natin ng bomb calorimeter. So, again, sabi natin, for a bomb calorimeter, negative yung Q reaction natin, tapos is equal to the heat of the calorimeter. So, bakit negative yung heat ng reaction? Negative yung heat of the reaction natin kasi siya yung nag-release ng energy, no? So, very true din dun sa discussion natin before na pag yung system yung nag-release ng energy, negative siya. And again, positive yung heat ng calorimeter kasi siya yung nag-absorb ng energy na nanggaling sa heat of the reaction. So, yan lang naman yung yan lang naman yung process natin for calorimetry. So, kung ano yung na-release na energy sa reaction, yun yung mapupunta lang sa calorimeter. So, again, pag na-encounter nyo tong formula, tas tatanungin nyo, bakit kayo negative to? Negative to kasi siya yung nag-release ng energy. So, bakit positive to? Kasi siya yung tumanggap ng energy. Okay, siya yung calorimeter mismo. Okay, so let's try to apply whatever we've learned from this constant volume calorimeter or bomb calorimeter to the following problems na sasagutan natin. Okay? So, one moment lang. Okay. So, basahin nyo muna yung tanong, no? Okay. So, quantity of 1.435 grams of naphthalene. So, aware naman siguro kung ano yung naphthalene, no? Yun yung tinatawag natin na mothballs, no? So, sila yung parang nilalagay natin sa cabinets, no? Sa mga sapatos to shoo away, no? Para hindi ipisin, no? So, yan yung mothballs natin. Okay, is a pungent smelling substance used in moth repellents, was burned in a constant volume bomb calorimeter. So, consequently, the temperature of the water rose from 20.28 degrees Celsius to 25.95 degrees Celsius. Okay? If the heat capacity of the bomb plus water was 10.17 kilojoules per degree Celsius, calculate the heat of combustion of naphthalene on a molar basis. That is, find the molar heat of combustion. Okay? So, yung formula natin kanina for bomb calorimeter is negative Q reaction is equal to heat of the calorie. Okay? Tapos, anong formula for calorimetry yung gagamitin natin? So, kung matatandaan nyo yung discussion natin kanina, sabi natin, for a bomb calorimeter, we use the formula heat capacity multiplied by the change in temperature. So, the reason why hindi na natin gagamitin yung mass dito, it's because we're dealing with the bomb calorimeter. So, imagine mo, diba, i-measure mo yung timbang niyan, mapapagod ka, mahihirapan ka, no, to facilitate the calculation. Okay, so because of that, magiging negative Q reaction to is equal to the heat capacity times the change in temperature. So again, pwede na nating ilipat yung negative sign sa kabila, no? So that is Q reaction is equal to negative heat capacity multiplied by the change in temperature. So very easy na naman to kasi straightforward lang yung formula natin, no? So again, binigay na dito yung heat capacity natin, which is given as 10.17. So that is 10.17 17, pangit tong 7 natin, barahin natin. So that is 10.17 kilojoule per degree Celsius times the change in temperature. So that is final, no? So that is 25.95 minus 20.28. Okay? So from here, pwede na nating i-cancel yung degree Celsius, tapos i-multiply lang natin yung heat capacity natin from the change in temperature. Yung sagot natin is negative 57.66 kilojoule. Bakit siya negative? Kasi nga, yung Q reaction, siya yung nag-release ng energy. Okay. Or yung system natin yung nag-release ng energy. But, students, no, hindi pa tayo tapos with this calculation. Okay. So, feel free to pause. Okay, mamaya na nyo i-pause, no? So, let me ask you a question, no? Bakit hindi pa to yung final answer natin? Okay, so, feel free to pause the video in this part para malaman nyo kung bakit hindi pa yung negative 57.66 kilojoule yung answer natin. So, I'm giving you time, no, to read the problem. Okay? So, okay no? Sagutin na natin yung tanong. So, bakit hindi pa tayo tapos? Kasi, based on the question above, sabi dito, calculate the heat of combustion of naphthalene on a molar basis. Pag nabasa nyo tong, etong term na tong molar basis, ang ibig sabihin lang yan is kailangan mong i-divide tong energy sa moles ng ating substance. Okay? So, kailangan mo munang hanapin yung moles ng substance natin, tapos i-divide mo siya doon sa nakuha nating energy. So, dapat yung unit natin dito is kilojoules per mole. Okay? So, pag molar basis, yung hinanap nating unit is kilojoule per mole. Okay? Paano natin hahanapin ulit yung mole? Anong formula natin? Ang formula natin dito is mass. Ang formula natin dito is mass over molar mass. Okay? So, using the formula here, no? Okay. Using the formula na mass is equal to molar mass, i-divide lang natin siya sa nakuha nating Q reaction dito. So, negative 57.66 kilojoules, no? Divided by, 1.435 grams over, ano yung molar mass natin? So, based on Google, this is 128 grams per mole. Okay, so that is 128 grams per mole. So, from here, cancel na yung grams. Tapos, pag kinalculate nyo ito, ang makukuha nating sagot ay negative 5,143.19 kilojoules per mole. So, ito na yung final answer natin. Okay, ulitin natin, no? Bakit kaya natin dinivide pa yung moles ng naphthalene? So, dinivide natin yung moles ng naphthalene sa energy na nakuha natin kasi yung problem is tinatanong tayo kung ano daw yung heat of combustion in a molar basis. Pag nabasa nyo yung salitang molar basis, kailangan yung unit natin is kilojoule per mole. Okay, so yan yung final answer natin. Negative 5,143.19. Okay? So anyways, try doing this problem, no? Okay? Di ko na sasagutan to. Basta yung makukuha yung sagot dito. Okay, sumobra ata to. Ito lang din ata yung nasa taas. Kasi naphthalene to. So, extra, lang to? Extra na slide. Pero hindi na natin gagamitin yan. Punta tayo dito sa kabilang problem. So, ito ulit, extra na slide lang to. So, hindi naman masyadong mahaba yung calculation. Kaya, hindi na natin gagamitin yung extra na slide na yun. But anyways, moving forward, no? Try natin sagutan to. Sige na nga, sagutan na natin to. Okay, so sabi dito sa problem, a quantity of 1.922 grams of methanol, CH3OH, was burned in a constant volume bomb calorimeter. So consequently, the temperature of the water rose by 4.20 degrees Celsius. So if the heat capacity of the bomb plus water is 10.4 kilojoules over degrees Celsius, calculate the molar heat of combustion of methanol. Okay? So, if we're going to use the formula natin kanina na na-discuss, which is Q reaction is equal to Q of the calorimeter. Tapos, in simplifying this will just simply be Q of the reaction is equal to negative heat capacity multiplied by the change in temperature. Okay? Given naman yung heat capacity sa atin, which is 10.4 kilojoules degrees Celsius. So, that would be negative 10.4 kilojoules per degree Celsius. Ngayon, siguro you might be wondering, no, asan yung temperature natin? So, as you can see, meron lang tayong iisang temperature dito. 4.20 degrees Celsius. Okay? Siguro, ngayon, nababasa nyo, hala, bakit iisa lang yung temperature? Hahanapin ko ba yung initial or hanapin ko ba yung final? Or vice versa, no? So, to answer that question, no, actually, yan na yung change in temperature. Kasi kung babasahin mo yung statement dito, sabi dito, consequently, the temperature of water rose by 4.20 degrees Celsius. So, for example, meron kang initial temperature, hindi mo alam kung ano yon. Sabi daw, itong initial temperature na to ay tumaas ng 4.20 degrees Celsius. So, meaning parang yung TF minus TI, ang difference lang nila is 4.20. So, automatically, ito na yung change in temperature mo. You don't have to look for the final temperature or the initial temperature kasi nakuha mo na yung change in temperature. So that will simply be multiplied by 4.20 degrees Celsius. So from here, based on the calculator na ginamit ko dito, this is negative 43.68 kilojoule. Okay? Again, hindi pa tayo tapos dito kasi based on the problem, we're looking for the molar heat of combustion of methanol. Or kailangan nating hanapin yung unit na kilojoules per moles. No? So because of that, we're going to divide this energy that we've calculated using the moles of methanol. So again, yung molar mass ng methanol is 32 grams per mole. Okay? So using the formula na na-establish natin sa taas, which is simply your energy or your heat of reaction divided by your mass over molar mass. So, yan yung formula natin na na-establish sa taas. So, that is simply negative 43.68 kilojoules over, ano yung mass natin? 1.922. So, that is our mass, no? 1.922 grams over yung molar mass natin is 32 grams per mole. Okay, so cancel yung grams. From here, yung answer nating makukuha is negative 727.24 kilojoules per moles. So itong negative 727.24 kilojoules per moles, ito yung tinatawag nating molar heat of combustion ni methanol. Okay? So, bakit siya ulit dinivide sa mole? Kasi yung pinapahanap sa question ay yung molar heat of combustion. So, ito yung tinatawag nating molar heat of combustion. Okay? So, yun lang yun. Very easy, no? Napakadali lang i-apply yung calorimeter. Okay? Moving forward, again, this slide is sobra lang. Okay. So now, let's move on to our coffee cup calorimeter. So, explain natin. So, sabi natin kanina for a coffee cup calorimeter, this is the constant pressure calorimeter. So, dahil ito yung constant pressure calorimeter, yung heat na makukuha natin dito is actually our enthalpy. And then, for the bomb calorimeter, yung heat na makakalculate natin doon is actually the internal energy. So, paano natin ina-apply yung concept ng coffee cup calorimeter? Okay, so one moment lang, no? Inom lang ang water. Okay. So, ina-apply natin yung coffee cup calorimeter pag meron tayong constant pressure na setup. So, actually, itong coffee cup calorimeter, madali lang to gawin, no? Dahil it doesn't require any special instrument. So, from the word itself, no? Or from its name itself, sabi dito coffee cup. So, paano ba yung setup dito? So, actually, no, kung hindi nagkaroon ng pandemic, or rather, pag pinayagan tayo ng face-to-face, we can actually do this, no, in the laboratory. Kasi nga, wala namang specialized instrument for a coffee cup calorimeter experiment. So, ang process dito is that, as you can see, meron kang styrofoam cup. So, kaya nga siya tinawag na coffee cup calorimeter kasi we're using styrofoam cup. So, meron kang styrofoam cup and then pagpapatungin mo lang sila at lalagyan mo ng takip. So, yung takip, it could either be a rubber or a cardboard. Then, maglalagay ka ng thermometer sa loob kasi yung thermometer, of course, siya yung magre-record ng changes, no? kung ano man nangyayari dun sa loob. And then, meron ka rin panghalo. Okay? So, yung stirrer mo dyan is pwede mong swirl para mas maghalo kung ano man yung paghahaluin mo sa loob ng ating coffee cup calorimeter. And then, from there, no, depending on what's going to happen inside, magkakaroon ka ng temperature reading, and yung temperature reading na yun yung heat, or rather yun yung energy na nangyari within that calorimeter. So again, no, same pa rin siya dun sa sa natin kanina sa bomb calorimeter, which is negative Q of the reaction. Bakit negative yung heat of the reaction? Kasi siya yung magre-release ng energy, and then that is equal to the heat of solution. Okay, something na parang mas madali nyo maiintindihan, no, is pwede rin natin actually, pwede natin i-interpret tong process ng ganito, no? So, let's say pangit ang drawing. Palitan ko lang yung kulay ng pen para hindi masyadong Okay, so let's say, ito, no, meron kang calorimeter. Again, from this calorimeter, may ilalaglag kang ball. Okay? So, lagyan muna natin ng water. Okay? So, may ilalaglag kang ball, and then yung ball na yun is mainit. Okay? So, itong ball na yun is mainit. Okay. So, dahil mainit yung ball, tapos meron kang water, ano yung mangyayari with this particular reaction? No? Siyempre, ang mangyayari dito is that the heat, kasi mainit yung ball, so the heat from the ball will actually be transferred to the water. Okay? So, for example, mainit nga yung ball natin, so yung energy na meron sa ball, matatransfer lang sa water. So, pwede nating i-interpret tong coffee cup calorimeter as if na parang negative Q ball is equal to the heat of water. Kasi si water yung mag-a-absorb ng energy ni ball, kaya siya positive. And then, negative yung heat ni ball kasi siya yung magre-release ng energy. Okay? So, yun lang naman yung natin. Okay? So, yun lang naman yung coffee cup calorimeter setup natin. Very easy lang din, no? Okay? So, let's apply, the thing that we've learned for the coffee cup calorimeter dito sa problem natin down below. Okay? Zoom in natin konti. So, basahin lang natin muna yung problem, no? So, sabi dito, a lead pellet having a mass of 26.47 grams excuse me po, 26.47 grams at 89.98 degrees Celsius was placed in a constant pressure calorimeter of negligible heat capacity containing 100 ml of water. So the water temperature rose from 22.50 degrees Celsius to 23.17 degrees Celsius. Degrees Celsius. So what is the specific heat of the lead pellet? Okay? So let's try to visualize kung ano yung nangyari for this particular problem. So sabi daw dito, meron kang lead pellet kung saan meron siyang temperature na ganito, initial temperature na 89.98, no? And then place mo daw siya sa constant pressure calorimeter kung saan may 100 ml of water doon. So technically, drawing natin, palitan ko lang yung kulay ng pen natin. Okay. So let's say meron kang coffee cup calorimeter daw, may water yon, and then from the water naglaglag ka daw ng lead pellet. So ito si lead, no? Palitan natin, ayoko ng red. Let's say green. Okay, yung kulay green. So naglaglag ka ng lead pellet dito, no? So ngayon ang tinatanong dito based on the question is what is the specific heat, no, of the lead pellet? Okay? So, before we try to answer this question, let's try to look at the givens muna. No? So, let's start looking at the water first. So, start muna tayo sa water. Tingnan natin kung ano yung mga given sa water. So, for water, no, meron kang mass na 100 grams. Okay. So, bakit siya naging 100 grams? Binigay sa atin is 100 ml. So, we assume that 100 ml of water is equal to 100 grams. Kumbaga parang 1:1 yung ratio niya. Kasi ina-assume natin na yung density of water is 1 grams per ml. So pag 1 grams per ml yung density ng water natin, 1:1 lang yung ratio ng volume ng water to its mass. So, we assume that the mass of the water is 100 grams. Based on that assumption na yung density ng water is 1 grams per ml. Okay, from there, sabi dito meron siyang temperature initial which is 22.50 degrees Celsius. And then meron din siyang final temperature which is 23.17 degrees Celsius. From there, no, students, you can actually see na parang walang binigay na specific heat. Okay? So, dahil walang binigay na specific heat, sabi ko nga dapat memorize nyo yung specific heat of the water, which is given as 4.184 joule degrees Celsius and grams. Okay. So, joule grams per degree Celsius. So, yan yung specific heat natin for water. Okay, now let's look at ball. Tignan natin si ball kung ano yung mga given sa kanya. So, for ball tuloy, lead, sorry. Let's look at lead kung ano yung mga given sa kanya. So, as you can see, may mass tayo ng lead which is given as 24.47, sorry. 24.47, 26 pala. Hindi ko nabasa yun ng maayos. So, this is 26.47 grams. Yun yung mass ng lead pellet natin. And then, binigyan tayo ng initial temperature na 89.98 degrees Celsius. Ngayon, wala siyang, as you can see, wala siyang final temperature. And then, of course, yung pinapahanap sa atin is yung specific heat ni lead. Okay. So, nawawala yun. Okay. So, dahil wala tayong final temperature, no, let's look at the visualization na ginawa natin dito. Okay. So, as you can see dito, sabi natin kanina, meron tayong lead pellet. Tas yung lead pellet natin is nilaglag natin sa water. So, as you can see, no, yung lead pellet natin, mas mataas yung initial temperature niya kaysa kay water. So, meaning, yung lead yung magre-release ng energy from within itself to the water natin. So, ngayon, at a certain point, no, kapag may dalawa kang object na magkaiba yung temperature, so katulad nga sa situation natin ngayon, mas mainit yung lead pellet natin kesa sa water, at a certain point, no, as time goes by, there will be a time kung saan magiging equal na yung temperature ng water natin at saka nung lead pellet natin, or magiging equal na yung temperature nung dalawang object natin na magkaiba yung temperature. So because of that, no, kung ganun yung pwede nating maisip or ganun yung talagang nangyayari pag meron kang dalawang object kung saan pinagsama mo sila pero magkaiba yung temperature nila, tapos at a certain point magiging equal din yung temperature nila, we assume that of course the final temperature of lead is equal to the final temperature of water then. So that is simply 23.17 degrees Celsius. Okay? So, ganun lang natin hahanapin yung final temperature ni lead. Kasi again, magkaiba sila ng temperature, mas mainit si lead kay water, so magta-transfer ng energy si lead from water. And at a certain point then, magkakaroon sila ng equal temperature na. So, because of that, parehas dapat yung final temperature nung water natin and nung lead pellet natin. Okay? So, from there, we can actually calculate this problem na, no? So, let's try to calculate this. So, ang formula natin is negative Q lead, heat of the lead is equal to the heat of the water. Okay? So, yan yung interpretation din natin sa task kanina. So, that will be simply negative M lead tapos specific heat ni lead. So, bakit ito yung ginagamit nating equation? Kasi, specific heat yung hinahanap. So, yung formula na gagamitin natin is meron dapat yung mass. Okay? So, dapat yung change in temperature, which is delta T ni lead. Tapos, dito, sorry. So, from here, no, sa kabila naman, this will be mass of the water. And then specific heat ni water. And then yung change of temperature ni water. Okay? From there, pwede nating i-isolate yung yung ano ba hinahanap? Yung specific heat ni lead. So, pwede nating isolate to. So, divide both sides by negative MPB and delta TPB, no? So, negative MPB or ni lead, and then delta TPB. So, cancel to, cancel to, cancel to. And then yung formula natin is negative mass ni lead multiplied by the change in temperature ni lead. Okay? So, ito yung final formula natin. So, lagay natin dito to find the specific heat of lead. Ito yung formula natin na gagamitin. Okay? So, negative MPB delta TPB. Okay? Gamitin na natin yung mga values na nasa taas. So, for the mass of water, that is 100 grams. For the specific heat of water, that is 4.184 joules grams per degree Celsius. And then for the change in temperature of water, that is simply final minus initial, which is 23.17 minus 22.50 degrees Celsius. Okay? Okay, punta tayo sa baba. Negative mass ni lead, that is 26.47 grams multiplied by the change in temperature of lead. So that, that is 22.50 minus 89.98. Okay? Degrees Celsius. So ito yung formula natin. Medyo concern lang ako ng konti dito sa linya. Palitan natin para dire-diretso. Okay? So from there, no? Pause nyo to. Try to calculate this. So ano mangyari dito? Cancel si grams. Cancel si degree Celsius. Ang unit is joule gram per degree Celsius. So pang specific heat nga talaga. So okay, ang sagot natin dito is 0.16 joule gram multiplied by degree Celsius. So, ito na yung final answer natin. Ito yung specific heat ni lead pellet. Okay? So, ito lang, no? Very easy lang. Kailangan mo lang mag-derive ng formula. And of course, kailangan mong i-interpret yung problem natin, no? Again, bakit yung mass natin for water, 100 grams? It's because we assume that the density of water is 1 gram per ml. And because of that, 1:1 yung ratio nung ating volume of the water and mass of the water. So, 100 ml is equivalent to simply 100 grams lang din. And then, as you can see, bakit parehas yung final temperature ng water and final temperature ng lead? It's because of the process nga na sinasabi ng science kung saan if may dalawa kang matter, tas magkaiba yung temperature nila, tas pinagsama mo sila, at a certain point, no, their final temperature will be equal. No? So, because of that, yung final temperature ni water is same lang din sa final temperature ni lead pellet. Okay? And from there, ginamit natin yung equation 1 natin for calorimetry, which is mass multiplied by the specific heat multiplied by the change in temperature. Kasi nga, we're looking for the specific heat of lead pellet. And at the same time, this is not a bomb calorimeter. So, sabi nga natin, ginagamit natin yung second equation, which is, ang given is yung heat capacity pag yung process natin is bomb calorimeter. Okay? So, from there, ang sagot natin is 0.16 joules per gram degree Celsius. Okay? So, moving forward, last question na to. Sagutan na natin to. So, sabi dito, 30.14 grams of stainless steel ball bearing at 117.82 degrees Celsius is placed in a constant pressure calorimeter containing 120 ml of water at 18.44 degrees Celsius. So, if the specific heat of the ball bearing is 0.474 joule per gram degrees Celsius, calculate the final temperature of the water. Assume the calorimeter to have a negligible heat capacity. Okay? So, let's try to interpret ulit muna yung problem natin. So, again, meron daw tayong steel ball na nilagay or nilublob sa water. So, meron ka daw steel ball. Okay. Tapos nilaglag mo sa water. Okay? So, let's try to look at the given, no? So, let's start with the steel ball naman ngayon. So, for the mass of the ball, okay, that is 30.14 grams, no? For the temperature initial of the ball, that is given as 117.82 degrees Celsius. Tama? And for the specific heat of the ball, TIB to, TIB. Okay, barayin ko lang sandali yung equal dito. Okay, so TIB yan kasi temperature initial of the ball. And then lastly is yung specific heat ni ball, binigay na rin, that is CB. So yung specific heat ni ball is 0.474 joule gram per degree Celsius. Okay? For the final temperature of the ball, yun yung pinapahanap based on the problem. So calculate the final temperature of the water. So again, sabi nga natin na pag meron tayong dalawang object na magkaiba yung temperature, at a certain point, magiging equal yung temperature nila pag pinagsama mo na sila. So kahit sinabi dito sa question na calculate the final temperature of water, of course, you're also calculating the final temperature of the ball kasi nga equal lang naman yung temperature nung water and nung ball, no? So again, let's move forward to water. So for water naman, the mass of water is given as 120 ml. So assuming that our density of water is 1 gram per ml, that will be 120 grams. For the specific heat of water, that is 4.184. Again, dapat memorize to. And then lastly, yung temperature initial ni water is given as ano ba? 18.44, no? Degrees Celsius. So again, yung final temperature ni water yung hinahanap. Okay. So let's try to derive the formula for this one. So derive natin yung formula, no? So again, this is heat of the ball. Baba tayo ng konti para hindi siya malapit dyan. So start tayo dito, no? Sabihin natin dito, calculation. Okay. So, hinahanap natin is yung final temperature ng ating setup. So, yung final temperature na yun yung temperature ni water, and at the same time, yun din yung final temperature ni ball. Okay, so let's do the calculation. So, paano to? Negative Q ball is equal to Q of water. Okay, to simplify that will be simply mass of the ball, tapos specific heat of the ball, tapos the change in temperature of the ball. So dahil hinahanap pala natin is yung final temperature, expand ko na tong formula na to. So that will be TFB, tama? And then minus TIB, okay, or temperature initial of the ball, equal to the mass of water, specific heat of the water, and then the change of temperature of water, which is TFH2O, and then minus TIH, pangit. So that is TFH2O and TIH2O. Okay? So from here, i-distribute natin. Okay? Gamit tayong light orange. Distribute natin to dito. And then at the same time, distribute natin to dito. Okay. Marunong naman, no? Okay, let's try to do that. So this will be simply negative MB CB TFB. Tama? And then negative times negative, that will be positive. So that will be MB CB TIB. Okay? So from there, ganun din gawin natin sa kabila. That will simply be MH2O CH2O TFH2O. Okay? So wala siyang negative sign dito. So that will be negative MH2O CH2O and then TiH2O, or the temperature initial of water. Okay, ngayon, ang gagawin natin is pagsasamahin natin yung mga may final temperature and then pagsasamahin natin yung may initial temperature. So, automatically, ito, itatranspose ko sa kabila. Tapos, ito, na may initial, itatranspose ko sa kabila. Okay, so yun yung gagawin natin ha. Punta tayo dito sa baba. So, pag nangyari yon, ang magiging process natin, rather, ang magiging equation natin ay, medyo mahaba to, no? So, that will be M H2O C H2O T, ano yung nasa equation sa taas? TI. Okay, so that is temperature. Final na lang muna. Start muna tayo dito sa final pala, sorry. Okay, start tayo dito sa final. So, ipunta natin sa pinakagilid yung final. Okay? So, burahin ko lang sandali. Tignan ko lang yung equation sa taas. So, ang gagawin natin is, yung final na lang yung nasa left side. So, that is MH2O, CH2O, tapos that is TFH2O. Tapos, trinanspose natin, ito, diba? Itong orange part na to sa kabila. So, that will be positive MBCB TFB. Okay? Tapos, nasa kabila naman yung mga initial temperature. So, that will simply be, MBCBTIB. Tapos, di ba itong part ng equation na to, transpose lang natin sa kabila. So, magiging positive na rin yan. So, that is plus H2O CH2O. O to ha. Tapos, TiH2O. Okay? So, ito na to, no? Magkakasama na yung may final temperature. Magkakasama na rin yung may initial temperature. Okay? So, from here, again, anong hinahanap natin sa problem? We're trying to calculate the final temperature. So, something that we need to do here is we can factor this out, no? Para ma-separate natin yung final temperature. Again, sabi naman natin, yung final temperature ng water and ng ball is magiging equal at a certain point, no? Or rather, at a certain point, yung temperature ng water and ball maging equal. So, pares lang sila ng final temperature. So, factoring out the final temperature, this will be TF is equal to MH2O CH2O plus MB CB. Okay? Finactor out natin yung final temperature. So, finactor out natin itong part na to at itong part na to. So, ito na sila. Kasi parehas lang din naman yung final temperature nga ng ball and then nung water. Okay, moving forward, ganun pa rin sa kabila, wala tayong ginalaw. So, copyahin lang natin. Okay, so Ti H2O. Okay? Again, kailangan nating i-isolate tong temperature na to. So, meaning, etong part na to, lagyan natin ng sign. Etong part na to, i-divide ko dito. Okay? Para ma-isolate yung final temperature. So, yung final formula natin ay, ano yung final formula natin? Ang final formula is TF is equal to, copy mo nasa taas, MBCB TIB plus MH2 MH2O CH2O TiH2O over yung nasa kabila kanina. Mauna yung water para hindi tayo malito. MH2O CH2O plus MBCB. Okay, so ganito lang yan, no? Okay, ito na yung final formula natin. So, sobrang haba, no? So, let's try to input all the values na sinet natin dito sa taas, sa baba. Yun yung gagawin natin. So, Zoom out ka lang sandali. Okay, so yun yung gagawin natin, no? Ano yung mass ng ball? That is 30.14 grams. So, from here, multiply ko daw yung specific heat ni ball, which is 0.474 joule gram degrees Celsius times initial temperature ni ball, which is 117.82 degrees Celsius. Okay? Moving forward, plus yon. Okay, so mass naman ni water, that is 120 grams multiplied by specific heat ni water, 4.184 joule gram per degree Celsius times yung initial temperature ni water, which is 18.44 degrees Celsius. Okay, kumasya. So, from there, over na tayo. So, over sa baba. Punta tayo sa baba, which is mass ni water, 120 grams multiplied by the specific heat of water, 4.184 joule gram degrees Celsius plus mass ni ball, 30 rather 0.14 grams multiplied by the specific heat of ball, which is 0.4. Hindi negative yun. Baka malito tayo. Hindi negative to, ha? 0.474 joule gram degrees Celsius. Okay? So, ito na yung final formula natin, no? So, yan. Matuto na lang kayong gumamit ng bracket. Or ito, parenthesis lang to. Kaya yan ng calculator nyo. So, pag nagawa nyo ng tama to, or na-input nyo ng tama yung sagot nyo, ang final answer natin dito for the final temperature of water is 21.19 degrees Celsius. Okay? Again, kahit na pinapahanap sa question is final temperature ng water, parehas pa rin ang temperature ni ball and temperature ni water at a certain point. Okay? So, etong final temperature na to ay para kay water and kay ball. Okay? Ano natin? Clarify natin. Hindi siya dapat ganito. Dapat final temperature ni ball and final temperature ni water. So, same lang yun. Dapat. Okay? Based sa concept natin ng constant pressure calorimetry. So, that's it. Okay? That concludes our chapter 2 or our discussion for thermochemistry, specifically for calorimetry, no? So, again, no, students, your prelim exam will happen next week, no? So, your prelim exam is composed of 50 items multiple choice, so that is 2 points each. So, 50 times 2, that is 100 points in total. And then, yung passing rate natin for the exam is 60%. So, you need to get 60 out of 100 to pass your exam. So, technically, that is 30 items, no? Kailangan, out of the 50 items, you need to have 30 items na tama. So, coverage of your prelim exam will be starting from chapter 1, which is your chemical safety, and then chapter 2, thermochemistry. Again, di nakasama yung special chapter. So, yun lang yung coverage natin. Chapter 1 and chapter 2. Okay, so the prelim exam will happen through online examination, no? So, please ensure na yung specific date or yung date na minention ko sa GC natin is available kayo. I don't want to hear lame excuses, ha? Kasi the only time that you can take the exam is during that time frame. If ever binigyan mo ko ng lame excuse kung bakit hindi mo na-take yung exam, whether na malengke ka or kung ano man ginawa sa'yo, nag-overslept ka, hindi ko tatanggapin yung excuse na yon. And if ever man you have an excuse rather na ano naman, understandable, like for example, walang kuryente, internet connection is unstable, please document it. Okay? Anong parusa pag hindi nakapag-take ng exam sa specific time na binigay, or rather dun sa time natin, no? So yung magiging consequence rather is, yes, pagtitaken pa rin kita ng prelim exam para di ka naman bagsak, pero you need to take the exam face-to-face. So, magkaiba yung exam for face-to-face, iba rin yung exam for online. So, mas mahirap ng konti yung sa face-to-face kasi hindi siya puro multiple choice. Meron talaga siyang problem solving. So, kung ako sa inyo, kung ano yung sinet natin na time or schedule for your prelim exam, you should make yourself available that time. Okay? And if ever man that there are some circumstances that are, hindi natin ginusto, which is wag naman sana, then have a proper documentation, no? Hindi niyo ako gagamitan ng maging considerate ka, sir, kasi I've been very considerate from the very start, no? And again, pakisagutan na rin yung problem set nyo, which is posted na rin sa Google Classroom natin. Okay. So with that said, student, no, I will conclude our lecture at this point. So I'm hoping everyone, or rather not hoping, but I'm wishing everyone na sana makapasa kayo on our prelim exam para you will have that confidence, no? During our midterms, 'di ba? Mas maganda meron ka nung confident boost na pasado ko prelim, kaya medyo safe pa ako ngayong midterm. Kaysa naman yung maghahabol ka for midterm and final. So hopefully everyone will take our subject seriously. Walang magkakaram sana when it comes to reviewing chemistry, because trust and believe that hindi basta nakakram ang chemistry, no? So please have enough time for you to review for our prelim exam. Okay, with that said, no, I'll conclude our lecture at this point. So maraming salamat po.